Now the next topic, last topic is ecological succession. Ecological succession. Okay. So succession, what's the meaning of succession? One after the another. So you are a successor to your father, am I right? So one after the another is called succession. Here, in an ecological succession, when an ecosystem is destructed, what is the next? It's something coming out of them dead. Even if I completely destruct all the temperate forest, or if I consider I completely destruct this entire northeast forest and leave it for another 25-30 years, the same northeast, the same plant and animal will come back. This is something called succession. Now here, when you take a succession, broadly we have two types of succession. One is primary succession, the second is secondary succession. Primary succession is very simple. When the beginning, when the earth was in the rock form, or even a newly constructed pond or newly constructed dam, from the bare rock structure, if any succession happened, we call it as a primary succession. Secondary is once you create the full system, create the full vegetation, after that you destruct it any number of time, it is called secondary. Now I will first explain you. So you can just listen to me, that's nothing more than that. See, you take a rock, you leave the rock for many years, it's hundreds of years. You leave the rock, on the rock you will find some pioneer species like lichens and mosses. I already told you. They will come and they will also be responsible for the weathering. And then after some many years, you can see a small soil layer will come. Immediately the biotic will change. You can see some small annual plants will come. Further many years goes on, the soil layer further increases. You can see some grasses and perennials will come. Further many years goes on, the soil layer further increases, the nutrient level increases. You can see the intermediate species, the vascular plants, the plant with xylem and phloem will come. And then further many years goes on, you can see a good amount of soil would have come with all nutrient, and air oxygen also would have been increased by this primary producers. And you can see finally you will come to a stage called climax community. Listen here, when I use the word community, it's a plant and animal. Community means it's a plant and animal. This is called community. All the plant and animal together is called community. Okay. Now, here, if you ask me what is a climax community is, it is the best plant and animal adapted to the best climate. See, that is the biotic and the abiotic, or the abiotic and the biotic has come equilibrium. So whatever the water, air, soil, whatever the abiotic condition, according to that, you will find a best biotic, all the plants and animals. That is something called climax community. Definitely it would have taken many years or thousands of years to come to this climax community. Okay, now let's see another example for primary succession. Again, let me take a temperate forest. The same way, it's a rock. On the rock, you can see after some years, lichens and mosses will come. Slowly the soil layer will come, weeds will come. Further the soil layer increases, grasses will come. Further the soil layer increases, shrubs will come. And then you can see young forest. Finally, you can see beech, maple. It's a temperate deciduous forest. So all the climax community comes. This is something called primary succession. From the scratch, if it starts, if it goes and reaches a climax community, we call it as a primary succession. Now, because of some reason, because of the natural or human activity, if this climax community is destructed, what will happen? Again, the succession will start. But whether it is going to start from the rock? No, already you have a lot of soil. See here, from the rock, this is a primary succession. Now this primary succession destructed. Now the secondary succession starts with the soil. Okay. See, within a few days or in a month's time, you will see weeds will come. In a year's time, grasses will come. In a few years, shrubs and young forests will come. Maybe after 20-25 years, the same forest will come back. So this is something called, hereafter again you destruct it, again it's called secondary succession. Hereafter any number of destruction you do, it is called secondary succession. See, if the invasive was introduced, means invasive also will come back. If you are not introduced invasive, then only the native will come back. See, very simple. According to the climatic condition, what can grow? According to the temperature. Temperature is a very important factor. Temperature, rainfall. When you have the temperature, rainfall, and other soil factors, the same plant is going to come. Okay, this is something called secondary succession. So what is the difference between primary and secondary? I will say primary, it has to start from the rock. Secondary, it has to start from the soil. Primary, it is very slow. It would have taken many hundreds and hundreds of years. Secondary is very fast. That's it. Okay, that is about the primary succession and secondary succession. Right. So now we have to see how the succession in the water. You just leave a water. You leave a water body for a long period of time. Slowly the erosion process will happen. Some deposits will come. Some perennials will start. Further years goes on. You can see weeds and all will come. Further many years goes on. The deposit will come and close it, and you will find grasses. And then further many years goes on. You will find an intermediate forest, and finally you see again the same climax community will come back. That is the reason they say whether it is a land or water, whether it is a dry or wet. You leave it for many years, it will come to one intermediate stage that is called mesic condition. It is neither too dry nor too wet. Then leave it for many years, it will come to a climax community. Okay, it will come to a climax community. So whether it's a land or whether it's a water, you leave it for many years, it will come to one stage, neither too dry nor too wet. It's a sort of an intermediate stage, and then it will go and end up in the climax community. So anything you leave it, it will come to a climax community. You destroy the climax community, again and again it will come back. This is, we call it as a succession. Now here, what are all the forests you see in this world? Everything has come to the succession, has come to the climax community. But some vegetation, some forest are not able to reach its climax community. For example, savanna forest. If you take savanna forest, it's a grassland. Most of the time, your savanna forest is getting interrupted here itself. They are not able to go to the climax community. Actually, the savanna forest, which is a grassland, tropical grassland, I will show you that they are supposed to reach the climax stage, but they are not able to reach the climax stage because of some reason. We will see that why they are not able to reach. Okay, this is, we call it as a ecological succession. Right? Which slide? See, you leave a water body, every day some deposits will come. But that erosion process, normally wind erosion and rainfall erosion will be there. Slowly it will get accumulated. But in order to slowly come to the stage, it will take many hundreds and hundreds of years. Most of the time we will go and interrupt because we do something called desiltation dredging. So generally we will not allow it. If you allow a lake, you leave it for many hundreds and hundreds of years, definitely it will come to the stage. Without cleaning or without disturbance, it will come. But most of the lakes we do go intervention, no? And our lifespan is 70 years. Now I'm talking about thousands of years. Am I right? So we have to wait and watch. Thousands of years it will take. It will take many, after many hundreds and hundreds of years only, it will come to the stage. You cannot see in our lifespan. It's not possible. Right? So that is about the ecological succession. Okay, yeah. Dry and it's between like dry and wet. It's a one intermediate stage. We will see the global terrestrial ecosystem. The major ecosystem we'll discuss. See, for this, you should be good in your pressure belts and wind belts because that decides your different climatic condition and different rainfall and temperature factor. Based on that, different vegetation is determined. Okay, that's how it determines your different vegetation. Now we'll give a small sort of a chart. Let me take this x-axis as a rainfall. This y-axis as a temperature. This is high temperature, this is low temperature. This is high rainfall. This is low rainfall. Now you come to the equator. In the equator, definitely you will find a high temperature and high rainfall. Because of that, you will find a tropical rainforest. Right? Now, little go above. The temperature is more or less is maintained, but the rainfall further reduces. Then it will get converted into tropical deciduous forest. Further you go above, the temperature is more or less maintained, the rainfall further reduces. It is a tropical grassland. We call it as a savanna. Further you go above, by the time you come to the 30-degree belt, you have a desert. So within a desert, you have a dry desert and moist desert. Okay. Now we are entering into temperate belt, 45 degree. Now, when you enter into temperate belt, definitely it is not possible to see this temperature and this rainfall. So obviously, the first one what is going to create is a temperate deciduous forest. Okay, further you go above, you get a temperate grassland like prairie, steppe and all. Maybe further you go above, you may find a temperate desert, some cold deserts also there. Now you are entering into subpolar. In the subpolar, you will see one single largest vegetation, that is coniferous forest, taiga forest. So in the entire stretch, you will see a coniferous forest. Further you go above, you will find tundra. Okay. Further you go above, you will find the polar ice cap, polar desert or polar ice cap. Now this is the pattern is determined across the earth. Right? In this, we will get into some of the important major ecosystems and vegetation. We will see some of the plant and animal adaptation. Climatic condition I will give you, but in the geography, if they have given any climatic condition, you take that as a final. Okay, and source, I'm going to use the source like IGNOU source. It's a graduation level book. I will give you a point. You can make note of it. Now let's come to the first one. It is your tropical rainforest. Tropical rainforest. Okay, so if you see the latitude, it's 10 degree north and south. So it's the first point, just make note, 10 degree north and south. You see this? Okay, can you tell me what would be the summer temperature and winter temperature? Summer will go to 35, but winter will never go less than 26. It is more than 26 degree throughout the year. So point number 2, more than 26 degree throughout the year. More than 26 degree throughout the year. And you will see humidity is 85% humidity. 85% humidity. And what is the rainfall here? 200 to 400 centimeter rainfall. 200 to 400 centimeter rainfall. Okay, sometimes they say that the rainfall is the rainfall 200 to 400 centimeter rainfall. It is from its own source. The rain, it is from its own source. What does it mean? It is from the evapotranspiration. It is by the evaporation transpiration. But in India, we have a northeast forest, Himalayas forest, Western Ghats. But the rainfall comes from the monsoon winds. Monsoon winds. That is not from the own source. So here, because of the evaporation and transpiration, most of the moisture comes, most of the rainfall comes. It goes in the convection, cumulonimbus clouds is formed. You can see 200 to 400 centimeter rainfall comes. Okay. Okay, that is all. Now you can see this, some of the major rainforest, our Amazon forest in the South America. You can see the Western African forest, Congo forest and all. And then you can see the North East Asian forest, sorry, East Asian forest, like your Malaysia, Thailand, and other thing. Okay, these are the, which is in the 10-degree north and south. These are the major tropical rainforests, one of the richest vegetation. Okay, we have to see the vegetation. So just make note, vegetation. Vegetation. We are going to see the vegetation. You see this? This is how a tropical rainforest will look like. Okay, the trees will grow very tall and forms multi-layered canopy. So listen to me here first. You see this? The trees will grow very tall, and you can see that it will form a canopy. So canopy, it's a very large canopy. Generally, they call it a multi-layer canopy. Normally divided into 4 layers, like emergent layer, canopy layer, understory layer. See, the canopy is a very large canopy. You can see this. Even you can put a platform and you can do a research. Such a large canopy you will find. Okay, so that is how this completely a very tall and forms a very big multi-layered canopy. So make note, point number 1, formation of multi-layered canopy. Formation of multi-layered canopy, broadly divided into 4 layers. Broadly divided into 4 layers. Okay, this is number 1. See, in this the canopy layer is very important. Now you can see that this canopy layer, it will block all your sunlight. Am I right? That is the reason at the bottom you will not find much light. Even you walk in the tropical rainforest in the morning, even in the afternoon 2 o'clock or 3 o'clock, it will be a little dark because the sunlight does not much penetrate, because all the sunlight is blocked by your canopy, the canopy. Okay, point number 2. Canopy blocks sunlight. Canopy blocks sunlight. Canopy blocks sunlight. Hence, pale light, hence pale, P-A-L-E, pale light, pale means dim, pale light enters forest floor. Pale light enters forest floor. Pale light enters forest floor. Okay, so it's going to be dim light. So when it is going to be dim light at the forest floor, how the vegetation will be in the floor, whether it will be rich or will be poor. Poor, because sunlight is not much penetrating, because your canopy blocks the sunlight. So point number 3, sparse vegetation, sparse, S-P-A-R-S-E, sparse. Sparse means less. Sparse vegetation at forest floor. Sparse vegetation at forest floor due to dim light. Due to dim light. Okay, the vegetation is going to be very poor. Sparse vegetation at forest floor due to dim light. Okay, you don't find much light, so vegetation is very poor. Then what will be very dominant here? Your commensalism. Just see this. At the ground level, you don't find much vegetation. And what is more dominant? climbers, epiphyte, commensalism. I told no morning. So that will be not commensalism, commensalism. So one is neither benefited nor affected, whereas the other is benefited. So that will be very dominant. Next is domination of climbers and epiphytes. Climbers and epiphytes. Epiphytes. Domination of climbers and epiphytes. Okay. Next, you see this. Suppose at the forest floor, anyway, the vegetation is poor. But by chance, you find any plant at the forest floor, how its morphological adaptation? First thing, you take a leaves, whether it is going to be a light green leaves or dark green leaves. Okay. So suppose at the forest floor, light green, but actually it will be dark green. Because the reason is at the forest floor, your sunlight is very less. Then how they can do photosynthesis? So by increasing the chlorophyll content, okay, you can see this right side, you see it, the leaves are very dark green. So even as a less sunlight, it will try to do photosynthesis. That is the reason if you see a leaf, you see here, it's a light green because it is directly exposed to the sun. So when they are directly exposed to the sun, they don't want much chlorophyll. But when they are not exposed to the sun at the ground level, definitely the leaves are dark green leaves. Okay. Second is, you see the leaf, whether the leaf will be thick or thin. See, adaptation is more related to the condition, logic and condition. There is a 200 to 400 centimeter rainfall. If the leaves are very thick, all the rainwater will get stagnated. Eventually, it will break it. That is the reason the leaves are very thin with a drip point. So when the rainwater touches, immediately it will bend and it will drip out all the rainwater. So the leaves are going to be thin with the drip points. So just make note. At forest floor, the leaves are dark green. The leaves are dark green to enhance photosynthesis. And the leaves are thin with drip points. To evacuate thin with the drip points to evacuate heavy rainfall. Okay. Then come to the pollination. See here, whether I told you pollination, two type of pollination. The one is the wind pollination, the second is the animal pollination. Within these two pollination, which will be dominant here? Animal, because since it's a canopies, your wind movement is very poor. So that is the reason here domination of animal pollination. So if an animal has to pollinate, as I already told you, the plant has to attract animal. Most of the time here, some of the plant and flowers, they will give a rotten meat smell. So to attract the animal, so that pollination can happen better. So just make note. Domination of animal pollination. Domination of animal pollination due to poor wind movement. due to poor wind movement. Okay. Then come to the forest. This forest is a very, you don't doubt at all, this is one of the richest forests in the world. How about the soil nutrients? Whether it will be rich or not. But actually it is not rich, it's very poor in nutrient because of the heavy rainfall leaching. Okay, so just make note. Soil is deficient of nutrient. Soil is deficient of nutrient due to heavy rainfall leaching. Due to heavy rainfall leaching. Heavy rainfall leaching. Okay, see, if the rainwater leaches all the nutrient, then how the plants are growing? See, without a nutrient, the plants cannot grow. So how the plants are growing if the rainfall completely leaches out the nutrients? So here the mechanism is the roots will ensure that if any decomposition happens near them, at the end of the decomposition, the roots will immediately absorb the nutrient before it enters into the soil. Okay, so in that way, so the roots will ensure that the decomposition happens near them. So just add on to it, full stop. Any decomposition happens near the root. Any decomposition happens near the root, comma. Any decomposition happens near the root, comma. The roots will immediately absorb. The roots will immediately absorb before it enters into the soil. The roots will immediately absorb before it enters into the soil. Before it enters into the soil. Full stop. Hence, all the nutrients are packed in the plant itself. Hence, all the nutrients are packed in the plant itself. See, competition will be there. Okay, but every plant will have some mechanism to survive. Okay, and then this forest, it is one of the biggest carbon repository on the earth. No, see, because of the rainfall, this forest is rich. So here, what is the biggest carbon repository means? They take the maximum carbon dioxide and gives oxygen. Of course, this is the lung of the planet, am I right? The maximum oxygen production is done to the earth only by the tropical rainforest. So next point is, it is big. It is one of the biggest carbon repository on the earth. It is one of the biggest carbon repository on the earth. It is one of the biggest carbon repository on the earth.